So previously we've learned the three basic trigonometric identities. Now in this video we're going to learn how to prove those three trigonometric identities. So let's begin. I'll begin with the first trigonometric identity, that is sine square theta plus cos square theta is equal to 1. So here theta basically refers to any angle, 10 degree, 20 degree, 100 degree, whichever one you want. So sine square of any angle plus cos square of the same angle is equal to 1. So now we want to prove this trigonometric identity. So what do? First step, take a right angle triangle. So I'll take a right angle triangle over here. Label this as triangle ABC. Next step is mark any acute angle. So let's say I mark this angle as theta. Now though I'm proving this identity for an acute angle, still this is valid for any value of theta. That's why it's an identity. I repeat, though we're taking the proof for an acute angle, here we can take any angle, acute, obtuse, reflex, whatever you want, you'll get 1, right? So what do? Once you have marked an angle, what is the next step? Label the perpendicular, base and hypotenuse. So side opposite the 90 degrees, so AC is the hypotenuse over here, right? Next, side opposite to the angle BC, this over here is the perpendicular, and side adjacent, this over here is the base. Now what is the next step? Find the value of sine theta and cos theta. So I'll do it over here. That is sine theta is equal to, what is the definition? Perpendicular by hypotenuse. That is equal to, what is perpendicular? It is BC. What is hypotenuse? It is AC. Similarly, we'll get the value of cos theta. So cos theta is equal to base by hypotenuse. So base by hypotenuse, that is equal to, which is the base? AB, which is the hypotenuse? AC. Now start with the LHS. So we have sine square theta plus cos square theta, right? What is the meaning of sine square theta? It basically means sine theta the whole square. So I'll write sine square theta is basically sine theta the whole square plus what is cos square theta? Cos theta the whole square. So now let's plug in the values. What is sine theta BC by AC? So BC by AC the whole square plus what is cos theta? AB by AC the whole square. So let's simplify this. So this is BC square upon AC square plus AB square upon AC square. Denominator same as the numerator. So we get AB square plus BC square upon AC square. So this is what we are getting. Now what is AB square plus BC square? AB square plus BC square. So sum of the length of two legs, the squares is equal to hypotenuse, Pythagoras theorem. So see, recall, we'll apply Pythagoras in this. In triangle ABC, we know that AB square plus BC square is equal to AC square. Why? Pythagoras theorem. So I'll mention over here, Pythagoras theorem. So we have AB square plus BC square. So AB square plus BC square is equal to AC square. So we get AC square upon AC square. AC square divided by AC square, that is equal to 1. Is this clear? So basically we have shown that sine square theta plus cos square theta is equal to 1. So this implies sine square theta plus cos square theta is equal to 1. So this is how you prove this identity. I repeat, just take a right angle triangle, mark this angle as theta, label your perpendicular, base and hypotenuse. Now just apply Pythagoras in this. So AB square plus BC square is equal to AC square. Next, we want sine and cos. So what is sine theta? BC by AC. What is cos theta? AB by AC. Just write down sine square theta plus cos square theta, plug in the values. We get AB square plus BC square by AC square. Now what is AB square plus BC square? AC square. So AC square by AC square, that is equal to 1. So sine square theta plus cos square theta is equal to 1. So this is how you prove this trigonometric identity. Similarly, let's prove the second trigonometric identity. So we have 1 plus tan square theta is equal to sec square theta. So again, the approach is the same. First step, draw your right angle triangle. Call this triangle ABC. So choose an acute angle. Let's say I choose this one. Mark this as theta. See, what is theta? It is basically an angle variable. Just like for numbers we take x. So typically for angles we take theta. It's a Greek symbol, right? This represents some angle over here. Next, label your hypotenuse, perpendicular and base. So this over here is the hypotenuse. Side opposite to the angle is the perpendicular. So BC is the perpendicular. Side adjacent to it, AB is the base. Is this clear? Right? Now, we'll start with the LHS. So we have tan theta and sec theta in this identity. So let's first find tan theta and sec theta. I'll do it over here. So tan theta, what is the definition of tan theta? It is perpendicular by base. That is equal to, which is the perpendicular? BC, which is the base? AB. So we have the value of tan theta. Similarly, next we have to find sec theta. So what is sec theta? It is basically reciprocal of cos. What is cos? Base by hypotenuse. So reciprocal, hypotenuse by base. So hypotenuse by base, that is equal to hypotenuse AC upon base AB. Is this clear? So now we'll solve the LHS and RHS. So give the heading LHS. So in the LHS we have 1 plus tan square theta. So let's plug in the values. So this is 1 plus tan square theta means tan theta the whole square. What is tan theta? BC by AB. So tan theta is BC by AB the whole square. So let's simplify this. So 1 plus BC square by AB square. Then we can simplify 1 into AB square plus BC square into 1, BC square upon 1 into AB square, that is AB square. Is this clear? Now what is AB square plus BC square? We already know it. It's AC square. Why? Pythagoras theorem. So this is equal to AB square plus BC square is equal to AC square upon AB square. Why? You can mention in bracket Pythagoras theorem, like we saw in the previous identity. So Pythagoras theorem. So the final value we're getting over here is AC square by AB square. This is the value of LHS, right? Now, what is AC by AB? I repeat, what is AC by AB? AC by AB is basically sec theta. I repeat, see, what is AC by AB? It is sec theta. So I can rewrite this as AC square by AB square is nothing but AC by AB the whole square, right? And we already know AC by AB is sec theta. So this is basically sec square theta, that is equal to the RHS. Is this clear? So we have shown the LHS is equal to RHS. So therefore this implies 1 plus tan square theta is equal to sec square theta. So hence we have proved this. So this is how you prove this identity. I repeat, first step, take your right angle triangle. Now this identity involves which trigonometric ratios? Tan theta and sec theta. Get the value of tan theta, sec theta. Start from the LHS. We have 1 plus tan square theta. Plug in the value of tan theta. Simplify, we reach AB square plus BC square. What is AB square plus BC square? AC square by Pythagoras theorem. So we get AC square by AB square, which is basically AC by AB the whole square. Now what is AC by AB? AC by AB is basically sec theta. So sec theta the whole square, that is sec square theta. So 1 plus tan square theta is equal to sec square theta. Is this clear? So this is how you prove this trigonometric identity. So similarly, we'll prove the third trigonometric identity. So we have 1 plus cot square theta is equal to cosec square theta. Approach remains the same. First step, draw your right angle triangle. So we have right angle triangle ABC. Then mark an angle as theta. Theta is nothing but a variable, right? It represents some value. Next, mark your hypotenuse, perpendicular and base. Side opposite the 90 degrees. So AC is the hypotenuse. Side opposite this angle BC is the perpendicular. And AB remains. So this over here is the base. Next, what are the trigonometric ratios involved in this identity? Cot and cosec. So let's get their values. So first we have cot theta. Now what is cot theta? It is basically reciprocal of tan. Tan is P by B. So cot is other way around. So B by P. Base by perpendicular. So let's plug in the values. What is the base? AB. What is the perpendicular? BC. So we have the value of cot theta. Similarly, we'll get the value of cosec theta. So we have cosec theta. Cosec is reciprocal of sine. What is sine? Perpendicular by hypotenuse. So cosec hypotenuse by perpendicular. So hypotenuse by perpendicular, that is equal to hypotenuse AC, perpendicular BC. Is this clear? Now let's prove the identity. So we'll start off with the LHS. So LHS we have 1 plus cot square theta. So let's plug in the values. This is equal to 1 plus, what is cot theta? AB by BC. So cot theta, cot square theta, so the whole square. So this is equal to 1 plus AB square by BC square. Here denominator is 1, let's simplify. LCM is what? BC square. So we get BC square plus AB square. Now what is AB square plus BC square? AB square plus BC square is equal to AC square. Why? Pythagoras theorem. So this is AC square upon BC square. In bracket we'll mention Pythagoras theorem. So Pythagoras theorem. Right? So we have AC square by BC square. I can rewrite this as AC by BC the whole square. Is this clear? Now what is AC by BC? AC by BC is clearly cosec theta. So AC by BC is cosec theta. Right? We have square, so cosec square theta. So we have 1 plus cot square theta is equal to cosec square theta. Right? So I'll write it over here. So 1 plus cot square theta is equal to cosec square theta. So this is how you prove this trigonometric identity. So basically we have gone through the proofs of the three basic trigonometric identities. I repeat, which are the three identities? Sine square theta plus cos square theta is 1. 1 plus tan square theta is cot square theta. And 1 plus cot square theta is cosec square theta. Is this clear? So this is how you prove these three trigonometric identities. However, in the questions which we'll do, you don't have to follow this approach. In the questions which we'll do, we'll have to take the help of these identities as it is. Is this clear? So as we do examples, you'll understand. But as of now, if someone asks you, how do you prove these three identities? Then this is how you prove these three identities. Is this clear? It's really simple. Make your right angle triangle, get the trigonometric ratios involved in your identity, start with the LHS, plug in the values, apply Pythagoras, you'll get your answer. Is this clear? So this is how you prove these three basic trigonometric identities.